Hi, welcome back to my channel. In today's video, I am going to discuss the most fundamental component in electronics, that is, bipolar junction transistor. The BJT or bipolar junction transistor uses both electrons and holes as charge carriers, therefore, calling us bipolar means having charge carrier of both polarities. There are two types of bipolar junction transistor, NPN and PNP. Let's compare both. NPN and BJT have lightly doped p-type semiconductor between two n-type materials. These three regions are called as emitter, base, and collector. A junction is formed between emitter and base is called emitter-base junction or EBJ, and another junction which is formed between collector and base is called collector-base junction or CBJ. Similarly, the PNP transistor have lightly doped n-type base between two n-types regions, and it also has two junctions which are emitter-base and collector-base junctions. Here are the symbols of NPN and PNP transistors. The arrow on emitter in both symbols is inverted, showing the direction of current flow is opposite in both transistors. The function of emitter is to supply charge carriers while base is the controlling element. The collector collects the charge supplied by the emitter. Now there are three modes of operation of BJT. The first one is the cutoff mode, in which both emitter and collector base junctions are reverse biased. In active mode, the emitter base junction is forward biased while the collector base junction is reverse biased. The third mode is saturation mode, in which both junctions are forward biased. The most important mode of BJT is active mode, because in this mode, the BJT acts as voltage controlled current source, which is the reason of BJT to be used as an amplifier. Let's discuss the active mode of BJT. As I have told you that in active mode, emitter base junction is forward biased while the collector base junction is reversed biased. To operate BJT in active mode, a condition must be met. The condition is, collector voltage Vc must be greater than base voltage Vb and base voltage must be greater than emitter voltage Ve. Let's draw the circuit and see how we can do this. We will use two external voltage sources, Vbe and Vce, to establish the required biased conditions for active mode operation. Let's suppose Vce is 1 volt and Vbe is 0.8 volt. Here, the collector potential will be at 1 volt due to Vce. Let's check whether the transistor is operating in active mode or not. Putting values of Vc, Vb, and Ve in above condition, we see that the condition is true, so it means that the transistor is operating in active mode. Now let's see what happened inside the transistor. For this, the same circuit is redrawn but with the structural view of BJT. To understand it in more easy way, we can replace the both junctions with the diodes, one diode for the emitter base junction and other diode for collector base junction. Now let's suppose, if we have a diode, and it has lower potential at anode side, and higher potential at cathode, obviously it will be reversed biased. In our case, the collector base junction diode is experiencing 0.8 volts at anode, and 1 volt at cathode, so it will be reversed biased. Now as the base emitter junction is forward biased, the emitter will supply or emit the electrons. When these electrons will pass through the base region, only 2% will recombine with holes due to the light doping of base and will create base current. The remaining 98% electrons will experience strong electric field, which is built due to the depletion region and reverse biased voltages, so collector will attract or collect the 98% electrons and it will form collector current. Now there is an interesting story ahead. There is a very important equation, which describes the relation between IC and VBE. The equation is, IC equals, IS into exponential power VBE, over, VT minus 1. This equation is called SHLAY Equation, and it is the fundamental equation which is applicable only when BJT operates in the active mode. This equation is not valid for other modes of BJT. In this equation, IC is the collector current, IS is the reverse saturation current, and its negligible current. It flows when base emitter junction is forward biased. VBE is the base emitter voltage, and VT is the thermal voltage. At room temperature, the value of VT is approximately equal to 26 millivolts. Now if we focus on above equation, the equation tells that IC depends on VBE and surprisingly, not on VCEE, which is strange. So if we have constant voltage at base, the BJT will behave as constant current source, or you can say it as voltage controlled current source, because the collector current is being controlled with base emitter voltages. Now if we plot the collector current versus VCE, a constant region will denote active region. BJT as constant current source have many applications, including amplifiers, current mirrors, voltage controlled oscillators, which we will discuss later. Please subscribe my channel and thank you for watching this video. See you in the next video.